Assalamu alaikum and a good day to all the viewers watching this webinar. I am Dr. Abdurrahim Sadiq Bacha, Associate Professor, Department of Electrical and Electronics Engineering, Faculty of Engineering and Built Environment, Masa University. On behalf of Faculty of Engineering and Built Environment, I would like to welcome all the viewers watching this webinar. Today's session is the keynotes, webinar session is delivered by Mr. Kasirajan. He is a senior lecturer in Faculty of Engineering and Built Environment. He has 20 years of experience in teaching and research. He has obtained his master's from Anna University, Chennai, in the specialization of power electronics. He got his bachelor's degree from Government College in the area of electrical and electronics. His research area is mainly on solar energy, electrical vehicles, and power electronics. He got a patent from the prestigious award, and this is from a robotic system charging battery quality in manufacturing industries using artificial intelligence. Mr. Kasi is doing many researches in the area of solar and especially in electrical vehicles. He is currently doing a project in electrical vehicles using solar. It is his current area of project. So the today's session is a very interesting session, which is on electrical vehicle charging techniques. So I leave this platform to Mr. Kasi to deliver his speech. Welcome, Mr. Kasi.
Thank you, Prof. Sadiq. Hi, good evening all. Today, it is a more recent emerging topic, electric vehicle techniques. Presently, we are using cars which is used with the help of fossil fuels. But fossil fuels, due to the fossil fuels, the vehicles emitting the unwanted gases and polluting the nature. Due to the pollution, the global warming occurs. It will heat up our Mother Earth. So we have to go for an alternative source, that is electric vehicle. Are you want to change the world with the help of electrical vehicle? Please come, let us do. Main objective of today's webinar is to create awareness about the electric vehicles and go green energy so that we can protect our globe. So outline of the webinar: progression of vehicle from bullock carts, isn't it, bullock cart, from bullock cart to electric vehicle. How we emerge from bullock cart to electric vehicle. Then what are types of vehicle, electric vehicle. Then types of charging, what are different type of charging existing. Wired charging, then what is wired charging and what are the benefits. Why we should go for solar charging. Then what about wireless charging? That is the recent hot topic, wireless charging. Then I will discuss about some projects. Then also for your benefit, I want to share on MATLAB wireless charging. It is developed by me, and what are the output results of wireless charging, then conclusion and future direction. Yes, now let us go into the webinar. In olden days, our grandparents and grandparents using bullock cart, some animal carts. Nowadays also existing, but now less number only. In olden days, we are using mostly the bullock cart for traveling and shifting the things from one place to another place. After that, invented the bicycle, then tricycle, auto rickshaws, diesel cars, petrol cars, then hybrid cars. After that, electric vehicles, electrical car. So, what is the progression of electric vehicle after certain years? For example, in the year 2050, mostly new car sales could be electric vehicles, and by 2070, almost all the cars could be electric vehicles only. So, based on the transport demands, so the fossil fuel vehicles will be decreasing in nature, but electric vehicle increasing in nature by year 2020, then 2045, then 2070. Likewise, the electric vehicle growth is enormous. So what are the types of vehicles? Basically, petrol and diesel vehicles using the fossil fuels, then gasoline, nuclear, then hybrid vehicles, combination of the petrol and electric vehicles, then electric vehicles. These are type of vehicles. Why we should go for electrical vehicles? It is pollution free, less carbon emission, also prevents global warming from some extent. Scarcity of oil after 40 years. So after 40 years, we don't know about the existing of fossil fuels. So that is very scary to us. So we have to go for another technique like electric vehicles. EV is clean and secure. Why EV is not coming up, electric vehicle is not coming up previously? Since it takes long charging time. Moreover, expensive compared to IC engines due to the presence of heavy batteries. Operating and maintenance costs were high compared to IC engines. Not enough proof for its safety. So there is no proof for the safety of electric vehicles. Around 1990s, lead acid batteries used and it is so heavy. So due to this disadvantages, the electric vehicles are not coming up. But nowadays, less weight batteries are invented. Due to that, the EV becomes focused nowadays. Moreover, wireless charging are also coming up. So inside the electric vehicles, what are the main components in the electric vehicles? We have electric motors, different kind of electric motors available. We know from basic to advanced. That is DC machines, DC motors, AC motors, that is induction motor and synchronous motors, synchronous reluctance motors, switched reluctance motor, PMSM, that is permanent magnet synchronous motor, brushless DC motor. So that is main for two-wheelers, brushless DC motors. PMSM for four-wheelers, we can use PMSM due to its nature and capacity. We can use the PMSM for four-wheelers. Then interior permanent magnet synchronous motor, that also very useful for the electric vehicles. So motor selection is very important for electric vehicles. So that is a very big topic. Depends upon the characteristics of the electric motor, we can select the motor, required motor for our electric vehicles. Then motor drive. So we need to drive the motor. After the advancements of power electronics, the motor drive becomes very famous. So with the help of the motor drive, we can drive the motor, which drives the wheels of your electric vehicles. Then power converters. So power converters, different power converters available like rectifiers, inverters. So these rectifiers, inverters are driven by the motor drive. So that output is given to your electric motor. Then battery bank. So battery is giving us the DC power. So for electric vehicles, we are using DC motors. With the help of the battery bank, we can drive the motors. Then onboard chargers. So onboard chargers available in the electric vehicle itself. With the help of the charging plug, we can charge the batteries. So charging plug in different countries, different type of charging plugs are available. And we need to study about the communication protocol. So with the help of the communication protocol, we can easily communicate with the electric vehicles for charging, how much the voltage is charged in the battery bank. So that type of communication is required. So we have to develop the protocols. Protocols means certain rules. We have to implement the rules in the communication so that we can easily communicate with the charging station to our electric vehicles. So battery charger. So these are some battery chargers available, DLS 90 up to DLS 15. So DLS 90 having more current, ingress current capacity, it can carries more ingress current up to 50 amperes. All are having more efficiency, more than 80% efficiency. And maximum AC current also 21 amps for DLS 90, and DLS 15 only carrying 3.5 amps. That is the lowest current carrying. So these are the battery charger ports. Then what are the types of charging? So now only we are enter into the main topic. So wired charging and wireless charging. Wired charging, with the help of the wire, we can charge the batteries of electric vehicles. Without wire, also we can charging the electric vehicles. So this is new. It is not existing, isn't it? What are the advantages of wired charging? Means reduced infrastructure cost, high power transfer efficiency. So high power transfer, we can transfer high power with more efficiency. Then possibility of high speed charging. But if the speed of charging increases, then definitely cost will be increasing. What about the maintenance cost? Low maintenance costs only for wired charging. Virtually no electromagnetic emissions, for wired charging. Then what are the disadvantages? Why we should go for wireless charging means, here in wired charging we need human intervention for connection. So with the human help we can charge. Not having any automated process. No automated process. The cable takes up space in the parking area. some it's space required for cable. Moreover, dust, debris, due to debris also it may get affected. So these are some disadvantages of wired charging. That's why we can go for wireless charging. Wired charging, what are different type of wired charging? There are basically four modes of wired charging. And basic charging, mode one is charging is basic charging. It refers to home charging. In our home, we can use this kind of charging from standard power outlets with a simple extension cord. There is no control. This charging does not provide users with shock protection. There is no shock protection available in the mode 1 charging against the DC currents. So no protection. Mode 2 charging, here it is a special cable with integrated shock protection. So it provides the shock protection against the AC and DC currents. Charging cable is provided with the electric vehicle. So with the vehicle it is available. Built-in protection in the cables, which protects the against the electric shock. Then most common mode of charging electric vehicles are mode 2 charging. Here control and communication network is available. So with the help of the communication we can develop the protocols. So how much the charging is done, how much time remains for charging. So that information can be shared by the charging station with the vehicle. So that kind of communication protocols are available for mode 2 charging, but mode 1 charging, that is no such communication. Then mode 3 charging, a dedicated charging station or home mounted wall box for EV charging is available. The connecting cable is provided with the wall box or charging station, and EV does not need a dedicated cable for charging. Currently preferred means of charging, this one currently preferred, this mode 3 charging only mostly we are using. Mostly we are using the CAN protocol for communication between the charging station and vehicles. Then last one is the mode 4 charging. It is DC fast charging. So with the mode 4 charging we can quickly charge the batteries. Even with half an hour we can do the charging. So it's also called as fast charge. Widely varying charging rates for mode 4. Currently starting with portable 5 kilowatts units through 50 kilowatts and 150 kilowatt plus, soon to be rolled out 350 and 400 kilowatt standards for mode 4 charging. So it is very fast charging, DC charging. Then electric vehicle onboard chargers and charging stations. Here different countries using different kind of charging. Okay, so in this case level 1 and level 2 charging stations using the first diagram, the top diagram indicates the level 1 and level 2 charging. Here we extract the power from the grid. So grid supplies the alternating current, AC current. So from the AC current it is given to the electric vehicle charging station. So from the charging station the AC is given to your AC to DC converter, that is OBC. OBC means onboard chargers. The onboard chargers converts alternating current to direct current. This is nothing but rectifier. We already studied in the power electronics, isn't it? In the power electronics, we might studied about the rectifiers. Rectifiers means alternating quantity is converted to direct quantity. So the OBC converts AC to DC. Then that high voltage DC is used to charge the battery pack. And here, if you see the pilot wire. The pilot wire is used for the communication purpose, purely for communication purpose. Initially, the charging station and the electric vehicle send signals between these two, thereby whether the electric vehicle is ready for the charging, and proper charging cable, that connection is available or not, that also communicated between the charging station and electric vehicle. If the not a proper cable means it will not charge. Okay, so for that purpose we need the pilot wire for communication, then only it will charge. When the charging is done, then indication is given to the charging station and blinking of light occur, then that we can disconnect the charging. So that kind of information is available here. So BMS means battery management system. So we can sense the temperature of the battery, then voltage, current, how much the voltage, how much current is flowing. So that information can be monitored and controlled by the BMS unit, battery management system. So this is about level 1 and 2 charging station. And level 3 charging station, this is purely DC charging system. Level 1 and 2 AC charging, this one DC charging. Here the grid gives the AC. In this type of system, we are having this stack of EVSC, that is electric voltage, electric vehicle charging place stack. Since the one stack is not enough to give high current and voltage, so that we need stack of number of plates added together so that we can get more amount of current and voltage. So for that purpose, we are using stack of plates. So that one gives us the high voltage DC. That high voltage DC directly given to battery bank here in this case directly, that is bypassing your OBC, onboard charging. Directly the high voltage DC is given to your BMS unit. Okay, here also we have the pilot wire. So pilot wire for communication purpose, and this type of chargers within half an hour, less than half an hour, it will charge the battery. But level 1 and 2, it takes long time for charging battery. For example, 8 to 16 hours it will take for charging, long time for level 1 and 2. But level 3, within half an hour, it will charge the battery bank. So charging station for level 1 to level 3, like that. Level 1, mostly we are using in the residence only, homes only, and level 2 commercial purpose, and level 3 supercharger, approximately 30 minutes for charging, and level 1 very long time, 17 hours it takes for charging. But level 2 commercial, approximately 8 hours, depends upon the charger power, isn't it? So for level 1, 1.44 kilowatt to 1.92 kilowatt only available. Level 2, 3.1 kilowatt to 19.2 kilowatt. But level 3, see, surprisingly very high power, 120 kilowatts to 240 kilowatts. That's why within very short time it charging the batteries. So this is fast charging DC charging station. So types of EV charging connectors. So basically two AC charger sockets and DC charger sockets. AC charger sockets, see here three kinds. One is JSAE 1772. This type of charging sockets are available in Japan and USA. And here they are using single phase supply only, and power rating is 7.4 kilowatt. Mostly they are using this kind of sockets. Then second case, monogas, it is used in Europe and Germany. This one power rating is 44 kilowatt and 63 amperes, three phase. So they are using the three phase supply. Then third can in AC charger is Legrand socket. This one used in France and Italy countries, and power rating is 22 kilowatt, 32 amps and three phase supply. And in the Legrand socket, there is a protection shutter also available to avoid some debris, anything like that. Then second case is DC charger sockets. In the DC charger sockets, CHAdeMO, that is used in Japan, and in Korea they are going to install this kind of sockets. And this one using CAN protocol for communication purpose, and 400 kilowatts. See, 400 kilowatts. And cars Nissan Leaf, Kia and Mitsubishi using this kind of DC charger sockets. Then GBOT, that one used in China and India, and this also using the CAN protocol, 237.5 kilowatts power rating. Mahindra Chinese EV vehicles are using this kind of DC charger sockets. Then Tesla supercharger. So this one, Tesla charging stations, CAN protocol use, and 135 kilowatt power rating for Tesla supercharger. So far, from the grid, naturally we are charging the electric vehicles. Now, the interesting point is renewable energy. From the solar also, we can charge the electric vehicles. Here, why we go for solar charging station to charge electric vehicle means, from coal and nuclear power plants, we get unclean electrical power. So we have to go for alternate energy. Here, putting power point using electricity from grid, you don't not using green energy, so it is also expensive, takes long time to charge. So that is one. Then another, it is more expensive. Recharging at public charging station is very expensive. Too many different payment systems, impractical, not enough charging stations. So this, due to these reasons, we are going for solar power charging. So we can charging at home with solar power system. So in the home itself, we can install the solar panels in the top, that is in the roof, as well as in the ground also we can install the solar power plants. Since it is 100% renewable energy, so if you are installing solar system in your house, that means you help our countries and save our globe by installing this solar power plant. That is purely the renewable energy source, isn't it? And this one independent from power companies, so we no need to depend upon the power companies if you are installing the solar power stations, and affordable with grid and prices. So that's why we are going for solar power charging station. And here solar panels with various different orientation and inclination. Mostly since the sun moves from east to west, so based on that we need to install the solar panels from north to south oriented. Then more sunlight, we can extract more sunlight from the east to west. So that's why orientation and inclination. Then wall box is an intelligent charging device. It can detect whether power coming from solar or not. So that kind of intelligent system available. So here also we give the install the communication protocols so that can easily understand whether it is coming from solar or not. It only communicates with solar system and electric vehicle and make sure that only charging with solar power. See, this is the solar system. From the solar panel, we get the DC power. That DC power is given to PV inverters, photovoltaic inverters. Inverters nothing but converting DC to AC. That AC is given to you for wall box. So wall box that converts AC to DC, and that DC is charging your batteries in your cars. And network remaining, if there is no car means the power generated from the solar panel can be exported to your grid network. Okay, also you can use for home appliances devices. Then what are the components needed for a solar charging station? EV charger, solar panel array, solar panel PV, different kind of solar panels available, isn't it? Mono crystalline, polycrystalline, then flexible. So these are fundamental solar panels. Nowadays, the multi-junction solar cells are under research. If we get the multi-junction, then get 40% efficiency. Compared to other, it is more 2 times greater than the monocrystalline. So the solar panel can be installed on roof or ground anywhere to get the solar power. Then battery energy storage system. So battery can store the energy, and during the night time, if we are going to home means during night time we can charge the electric vehicles from the batteries. Since evening time we can easily charge, but evening time there is no sun, so from the battery we can charge the electric vehicles during the night time. Then solid foundation in case of a standalone solar charging canopy. So we can install solid foundation, no need to go for earth directly. So with the help of solid foundation also we can install this standalone solar power station. So often used as steel-based plate that functions in ballast. So no foundation is required, simplifying the installation. Then intelligent software is required so that it can identify whether the power coming from the solar or not. One more important thing, our Massa University sponsored the solar panel for the students project. We are, as Prof. Sadiq mentioned, we are developing a solar car. It is processing at the, within 1 month we can completely finish the solar car. So special thanks to our Massa University. Our students also doing very interesting doing the project. Then solar-based electric vehicle charging station architecture. So from the solar array, we can charge the hybrid storage bank. Here, from the solar panel, DC voltage is coming, and it stores in the hybrid storage bank. And the DC is given as dotted line. Then from the control smart energy control system to inverter, DC only flowing. The inverter converts the DC to AC, and the AC is given to the EV charging station. If any vehicle comes, we can charge the electric vehicles with the help of the solar-based electric vehicles charging station. Yeah. So far, wired charging, then solar-based wired charging. Now, this is the most hot topic nowadays, wireless charging. Definitely, we can say the wireless charging rules the entire world due to its superior advantages. See, now only we are talking, but 100 years before, Nikola Tesla, he is the pioneer to this wireless charging. He tried to transfer energy from one coil to another wirelessly, about 40 kilometers away. He made 187 feet tall tower to broadcast energy. See, it is very surprising, isn't it? He managed to light 200 lamps from a 40-kilometer distance. Due to shortage of funding, the project was stopped. After 100 years, that project is led by Marin Sledge from MIT. So name of the project is Vitricity. That is wireless power transfer. So this is the image of Wardenclyffe Tower located near New York. So here, different techniques, that is energy transfer in near fields, nearby fields and far fields. So based on that, we have near field means with the help of electromagnetic induction. Based on that principle, it is working. You might studied about the transformer. So transformer actually work based on the electromagnetic induction only. So based on that, these ideas are developed. Then far field, distance field means electromagnetic radiation. In the electromagnetic radiation, further two, one is microwave or RF power transmission. Second one is light or laser power transmission. So these are still under research. Since safety is important, isn't it? So due to the safety factor, this one to under research. And coming to electromagnetic induction, further it is divided into two. One is magnetic field and electric field. Magnetic field as the inductors developing the magnetic field, and capacitor electric field. So electrostatic induction with the help of capacitor plates, we are developing this one, and magnetic field with the help of the inductors. This one ideas are developed. Electrodynamic induction. Here, inductive coupling and magnetic resonance induction. You might study it in the basic subjects. Magnetic resonance. So under resonance condition, XL equal to XC. That is maximum. So at resonance condition, maximum power can be transferred. So based on that concept, researchers try to send more amount of power from transmitter side to receiver side. Transmitter side, we can transmitter coils we can install in the under the road, and over the road the electric vehicles can move through the coils. In the electric vehicles, the receivers are installed. The receivers get the power, transmitted power from the transmitter coil, and it charges the battery. So based on that principle, magnetic resonance induction is implemented, and inductive coupling. So two coils are closely placed, and the power transfer from transmitter coil to receiver coil. Here, stationary wireless charging available. Dynamic means the vehicle is moving through the coils placed in the road. Okay. Then wireless power transmission, depending on the application, power ratings application. So we can go for the mobile charging, electric vehicle charging. So depends upon the application, power ratings, how much power, low power or high power. For mobile applications, low power is enough, but for electric vehicles, we need more power. And range of transmission, whether nearby or far away. So range of transmission, energy can be transferred to electric field, magnetic field, and electromagnetic waves. Depends upon these three factors: application, power rating, and range. Then depends on the distance. Wireless power transmission can be near field. Near field means inductive power transfer, and far field means electromagnetic fields involved for power transmission. Then what are the applications of wireless power transfer? Due to its advantages, wireless power transfer used in mobile devices, electric vehicles, home appliances, then solar power satellites. So in the satellites also, solar power satellites also we are using the wireless power transfer. Then defense area also we are using the wireless power transfer due to its advantages. Okay, now the inductive charging is closely coupled. The two coils are placed nearby. So AC source transmitter, AC source supplies the transmitter current to the transmitter coil. The transmitter coil, due to the alternating means AC means alternating, isn't it? So alternating flux is created due to the varying nature of the flux. Self-induced EMF as well as mutually induced EMF both are developed. Self-induced EMF, that is in the same coil. Mutually induced means nearby coil is excited. So in the nearby coil, EMF is developed. That is mutually induced EMF. Since the coils are closely coupled, the more power we can transmit through the coils. And in the receiver side, induced AC voltage. So that AC voltage is converted to DC with the help of diode bridge rectifier. So the rectification, that process is called rectification, and that one, that DC is given to the R load. For example, equivalent resistance value of your battery. So this is closely coupled inductive charging. More power can be transferred for closely coupling. Then loosely coupled resonant charging. Here, the transmitting coil and receiving coil quite far away from distance. So here AC source alternating current. So due to the alternating current voltage, current is circulated and matching or compensation network is used to. Then magnetic field is set up in the transmitter coil. But since the receiver coil quite far away, less voltage only transferred, less power is transferred to the receiver coil. And here tuning is occurs so that we can transfer more power from transmitting coil to receiver coil. Then inductive power transfer system, how it works. Actually, for power transmission, we need high frequency AC signal. But the input supply is only 50 hertz or 60 hertz. So UK based countries 50 hertz. So here main AC source having 50 hertz AC, that is rectified, that is converted to DC with the help of rectifier, diode bridge rectifier used. That rectified DC is converted to high frequency AC with the help of AC inverter, and output of the AC inverter is alternating current. That alternating current flowing in the primary coil of the coupled system. So the alternating current flowing in the primary coil, due to the alternating current, flux is created. That flux links the secondary coil and mutually induced EMF is developed in the secondary coil. And this is the inductive link. And in the secondary coil, AC voltage developed. That AC voltage is given to rectifier for rectification. So that AC is converted to DC with the help of rectifier. Then DC is given to your battery for charging. So here we are using the high frequency converter, and secondary side EMF induced due to alternating flux. And the nature of the coupling is loosely coupling. Loosely coupled. Why means there is no core is used here. That's why it is said to be loosely coupled, and it is separated by air gap. So same diagram, the equivalent of this one, and this one input is a DC source, VDC. That VDC is converted to AC with the help of single phase inverter. So 4 switches are available, and AB is the connected to your LP, primary side inductor and capacitor CP. and that is output is VPRMS. VPRMS is available at the LP and CP, and this is primary side. Primary side resonance is due to LP and CP, and secondary side LS and CS. So due to this L and C, the resonance occurred in the secondary side, and we are getting VS RMS, that is AC only. That VS RMS is converted to DC with the help of diode bridge rectifier. Here, four diodes are used. We know the output of rectifier is pulsating in nature, not a pure DC, not flat DC. So pulsating DC, varying in nature. So we have to convert the pulsating DC to fixed DC. So we need some filter circuit. CF is the filter capacitor, which is used to convert the pulsating DC to pure DC. Then the pure DC only used to charge the batteries. So R naught is the equivalent resistance of the battery circuit. Okay. So that is about the inductive power transfer system. Then dynamic wireless power charging of electric vehicle. You know, one Israeli company, Electrode, they going to install electrified road. Daily they can install 2 kilometers by installing the coils in the roadside. So the electric vehicle can move over the road. While moving over the transmitter, that is coils, the electric vehicle gets charged. So that is called dynamic wireless. So what is the advantage of this dynamic wireless? Since while moving itself, it can get the charge. Then we don't bother about the battery capacity, since less battery capacity is enough for dynamic wireless. But static or wired charging means we need very big battery. Battery capacity should be high, and very big size batteries are required. But dynamic wireless means the battery capacity can be reduced, and small size batteries are enough for charging, and it can drive the electric vehicle. So that is the more advantage. So that's why I'm saying wireless power rules the entire world in future. So here, two lanes are there, lane 1 and lane 2. And in the lane 2 only, we are installing the transmitter pad. So here also two cases in the dynamic wireless power charging, also two cases. One is one big driver circuit, and others are driven by the big driver circuit. Always the transmitter coils are giving power, always. But in the second case, small driver circuit, and all these coils are not emitting the power always, not always. When the vehicle moves over the transmitter coil, then only the transmitter coil sends the electrical power to charge the battery. Otherwise, it will not turn on. So always the transmitter coil is turned off. After sensing the electric vehicle, then only it gives the electrical power to receiver coil. So for that, the communication protocols are playing a crucial role, so that it can communicate with the transmitter coil, communicate with the receiver coil, so that the battery gets charged. Here, since it is moving, and more harmonics are developed, so we need power factor correction. So we need the power factor correction network. So the three-phase supply is given to power factor correction network. so that we can get pure voltages. And rectifier converts AC to DC. Then that DC can be filtered by the capacitor, and we are using the H bridge. Then H bridge inverter, actually that DC is given to H bridge inverter, then inverter converts DC to AC, then that AC signal is given to transmitter pad. So from the transmitter pad it is send signals to receiver pad, which is installed in the electric vehicle. So this is, and moreover here two sensors, X sensor and Y sensor. If the vehicle comes in the same lane, that is in the lane 2, then the Y coil senses the battery, that is electric vehicle, and it gives the electrical power. And another one is X coil. X coil, that is if the vehicle coming from lane 1 to lane 2, then the X coil will give the signal. That is, it senses the electric vehicle, so that the electric vehicle comes from the lane 1 to lane 2, like that. So dynamic wireless power charging of electric vehicle. Here two sides, transmitter side and receiver side. In the transmitter side we have the VDC, that is DC, and that is converted to that is given to your this MOSFET. So MOSFET bridge, this is, we are using the MOSFET bridge. That DC is converted to AC with the help of MOSFET bridge, and that AC, high frequency AC, and this is given to the transmitter coil, and it consists of LPCP CZ for the resonance. Then in the receiver side also we have the inductor CZ CS LS for resonance. As I mentioned, VX and VY, VX and VY for lane 2 as well as lane 1 for sensing the vehicles, whether it is coming from the same axis or from nearby. So horizontal means X. VX senses the vehicle coming from lane 1 to lane 2. In the same lane means VY. VY senses that one, and it gives the proper signal to transmit. There is a receiver, from transmitter to receiver. And here we are having the signal processing circuit, which controls the control modulator and properly giving the firing pulses to the MOSFET, so that it is properly turned on and giving the high frequency AC signals. And in the receiver side, as we mentioned earlier, due to the coupling, it sends the wireless power to the receiver side, and that also AC. That AC is converted to DC with the help of diode bridge rectifier, and here we have the CNOT for filtering, and this secondary voltage is less, so we need to increase the voltage level. For increasing the voltage level, we are using the booster circuit. So booster circuit consists of LS, SS, and SC. Here SC is the another MOSFET, and with the help of the booster circuit, we can increase the level of voltage, and it charges the battery, VBAT means battery voltage. So battery management system, BMS, senses the voltage, battery voltage and battery current, and gives proper signals to the booster circuit. So here we are going for interesting topics, that is projects. Some researchers developed some projects for your benefit. I share my some aspects from the researcher point of view. And wireless power transfer, this researcher actually developed a small battery car, and he used ZVS switching technique. You know already, power electronics students know ZVS means zero voltage switching. When the AC signal crossing the zero voltage, at that time the switching occurs. Then we can reduce the losses. So that is the advantage of the ZVS switching technique. So that concept is implemented here. Okay, and here they are also using solar power for charging. Okay, then ZVS inverter and capacitor bank in the primary side as well as secondary side. Capacitor bank is used, and primary they are using the coils as lead coils. They are used for power transmission from primary side to secondary side at resonant condition. Maximum power is transferred from primary side to secondary side. Then secondary side we have the rectifier. The rectifier converts AC to DC, and that used to drive the motor. Okay, so bridge rectifier with 1 amps diodes in parallel for increasing the current capacity. So for increasing the current capacity, they are connected in parallel. Okay, mainly two things. One is zero voltage switching, and other one is solar power transfer. In another researcher developed transmitter and receiver coil. In the transmitter side, he used the DC power source, and it is given to the oscillator circuit. Due to the oscillations, the power developed in the transmitter coil, which is transmitted to the receiver coil. That AC is received in the receiver coil, that is converted to DC with the help of rectifier, and voltage regulator is used for regulating the voltage. So filter capacitors used for filtering purpose, and we need the constant voltage. So for constant voltage, we are using the voltage regulator IC LM7805. So constantly we are getting the 5 volt. So it is for powering a low power device. Okay, small project. Then high frequency wireless power transfer system for electric vehicle application. So this researcher actually using the TMS 320F 28035 for its operation. And primary side and secondary side, they are using the antenna for sending and as well as the receiving the signals between the transmitter side and receiver side. They are using mutual inductance. So they calculated the mutual inductance, magnetizing inductance, primary and secondary leakage inductance for no misalignment and 10 centimeter misalignment. If 10 centimeter away from the actual alignment, properly aligned, then how is the power transfer? So they analyzed like that. So if the transmitter and receiver coil are properly aligned, then we can send maximum power transfer as possible. So for that, they also tested for misalignment also practically. Based on that, they analyzed this network. So they developed like this transmitter system and receiver system. So they are using the DSP micro processor for their experiment. And this is the continuation of that one. And they concluded that a 500 watt lab prototype was designed and built and tested to verify the circuit performance of developed wireless power transfer charging system. So this result showed that volt to battery efficiency can be higher than 90%. So they obtained a 90% efficiency with only 15 centimeter air gap at 500 watts rated power and 120 volt input conditions. Another researcher designed a 3.3 kilowatt wireless inductive power transfer 95 efficiency, 95% efficiency over 10 centimeter air gap. Air gap is less compared to the previous one, but efficiency is more. They use the ferrite N95 core as receiver and copper coils as usual. Then PVC material also they use, and the dimension 300 mm about 300 mm, and voltage stress on resonant capacitors, primary side and secondary side they calculated, and turns number, self-inductance, coefficient of coupling, everything they designed and calculated for this experiment, and they reach more than 95% efficiency. For distance between the transmitter coil and receiver coil only 10 centimeters. And same researcher designed the inverter and rectifier model with MOSFET, this STY 139N65M5 series, and diode. They used DSC in 120 to 06 ampere. Research ideas. The researchers, what area they can concentrate. So analytical methods, numerical methods, and experimental methods. Analytical methods, equivalent circuit analysis, scattering parameters analysis you can do, and finite element analysis also. Then electromagnetic analysis, high frequency structured simulation using HFSS, coupled field and lump parameter analysis. Then experimental methods, you can verify S parameter measurements and parameter identification. S parameter is scattering parameter, and field measurements, power and energy transmission emission tests. So all this research area, you can do your research in these areas. Yeah, as I promised you, MATLAB example with the help of Simulink, I developed this one here, and primary side and secondary side. Primary side in the first DC supply, and here 4 IGBTs. I took 4 IGBTs, and see IGBT, diagonal IGBTs are gated with the same pulse width modulation, and another this one and this one using with the inverter, that is with the help of NOT gate. I invert the pulses so that at the same time the same legs IGBT should not be triggered. If same leg IGBT triggered means it is directly short circuit to your supply, so we have to avoid that one. So inverter with the help of NOT gate. Then we measure the current and voltage. With the help of current and voltage, we can calculate the power P and active power P and reactive power Q. So with the help of voltage measurement block and current measurement block, then the current can be increased with the help of gain, and that one captured in the scope. Then primary capacitor we use, and the inductors 1 and 2 closely coupled, this one, and current in the secondary side capacitor, and here we use a diode bridge rectifier. In the secondary side also we measure the voltage and current. Secondary side also we measure active power and reactive power, and this one displayed in the display boxes. So and lastly we use the resistor. Resistor is nothing but the equivalent value of your bat. So across that resistor we are measuring the voltage and display. Okay, so this is the primary side of transformer voltage and current values. So based on our input we get 400 volts, and current values 200, peak values 200, peak to peak is 400 amps, and voltage peak to peak is 800 volt. So this is input primary side voltage and current measured from the scope. Okay, so this one V and I. Then this is secondary side of transformer voltage and current values. So secondary side we get only 100 volt and current is around 25 amps. Sorry, one third only, around 20, 15 to 20 amps. Secondary side. And PQ values from primary side and secondary side we get like this, around the 1000, and reactive power is 0. Active power is around 1000, and this is the output voltage, 100 volts. We are getting the 100 volts in the scope 3. Scope 3 is our the battery voltage. Okay, so this is about the MATLAB wireless power transfer. Okay, these are some references. Okay, so that is the end of our webinar. I hope you enjoyed this webinar and it is very useful to you. And thank you for saving the earth by watching this webinar. I am very much thankful to Masa University and my friends and colleagues of Masa University. Thank you very much. See you. Bye bye.
Okay, thank you, Mr. Kasi, for your interesting and informative webinar. Is there any questions from audiences? You please put it in the chat box. And actually, basically, Masa University is focusing on the research areas, and they are providing a lot of funds for internal research, I mean, grants. Basically, in Faculty of Engineering, the researchers as well as the students involved in various research projects, especially in solar energy as well as electrical vehicles. If students who is studying in MASA, they have get exposure to the latest trends and researches. This is one of the benefit of MASA University students. Okay, finally, I thank you all the viewers. If you have any questions, you can directly link to Mr. Kasi. Thank you very much.
Thank you, Prof. Thank you.